Dear students, today we will see the next topic in the operational amplifier, in which we are going to see what do you mean by open loop configuration, and then we will see what is a comparator circuit, and then we will see what are the limitations of open loop configuration. Okay. Now, basically, first we will see what do we mean by open loop. Okay. So, open loop or configuration of op-amp. Okay. So, operation amplifier is an open loop. Now, whenever we say open loop, that indicates that there is no a connection between the input and output terminals. So just remember this general statement. Whenever we say open loop, that indicates that there is no a connection between input and output terminals. So op-amp, whenever it is drawn, it has two input terminals, and the difference of the two input terminals is amplified. Okay. So here you can see these are two input terminals, minus, plus. So this is your V2, this is your V1, and output will be V0. Okay. Now there will be no connection between input and output terminals. So this will not be there for open loop configuration. Okay, so open loop configuration, there is no connection between output and input. So there is no feedback. It is not closed. It is open. Okay, that is why we call it as open loop. Okay, so in case of amplifiers, the term open loop indicates that no a connection exists between input and output terminals of any type. That is, the output signal is not feedback in any form as part of the input signal. In open loop configuration, the op-amp functions as a high gain amplifier. So if you see the output here, the output voltage will be, okay, a gain multiplied by difference of the two input voltage. So this gain will be very high gain. Okay, very high gain you have for an open loop configuration of op-amp. So whenever you have a circuit which is having open loop, there is no feedback from output to input. In that case, the op-amp will have very high gain. The output might saturate to its levels of positive polarity and negative polarity, but the gain will be very high. Okay, the gain will be very high. The output, which is the difference between the two input voltages, will be very high at the output. Okay, so here the term open loop indicates that no feedback in any form is fed to the input from the output. When connected in open loop, the op-amp functions as a very high gain amplifier. Then this is what we had seen as a symbol of op-amp. So as a symbol of op-amp, it is having two inputs. One is inverting input minus, and one is non-inverting input plus. So here you can see you are having this inverting input. This is your inverting input, which is given to a minus point. So this terminal is your inverting input, and this is non-inverting input. Okay, so this is given to the plus point. Okay, and here you get the output. So output V0 should be gain gain multiplied by V in at the inverting input. Sorry, V in at non-inverting input minus V in at inverting input. Okay, so it will be the difference between the two inputs here. Whatever you have a difference between the two inputs here, whatever you have difference voltage, the difference voltage will be amplified here. So output will be the multiplied gain into the difference voltage. Then if you go to see a comparator circuit, okay, so here we have shown a simple a comparator circuit. So this is a comparator circuit in open loop configuration. Okay, so here you can see, so let this supply be some voltage applied here. Okay, now that voltage is going through a resistance here, R1. Okay, and that is taken as a reference voltage at the non-inverting terminal. Sorry, reference voltage at the inverting terminal minus. Okay, similarly, you give one input at the non-inverting terminal. So here you can apply a certain input. So this input you can apply here with respect to ground. You can apply some input here. Now this input and this reference voltage can be a DC voltage. and this can be a alternating voltage. So these both you can give to the op-amp. Now, because the op-amp is going to amplify the difference between the two inputs, it will amplify the difference between this V reference and the input whatever you are applying. That means in a way it is going to compare the two inputs. It is going to compare the two inputs, and the output will vary depending on which input is increasing and which input is decreasing. That is your comparison circuit. Okay, so if you see here in a form we have given here, same thing. This is the input voltage whatever we are applying to the non-inverting terminal plus, and this is the reference voltage what we are applying to the inverted terminal minus, and output will be given as the comparison. Okay, if V in, that is the input voltage, is greater than reference voltage. Okay, if say this is the reference voltage and this is the input voltage. Now if input voltage is greater than the reference voltage, okay, that is V in is greater than Vref, then the output will go to positive saturation. Positive saturation. Similarly, when the input voltage is less, as you've shown here with respect to reference voltage, that is, then the output will go to negative saturation. Okay, so the output will be either plus VCC or minus VCC, depending upon whether the input is more than the reference voltage or input is less than the reference voltage. So output will be like a square wave. Okay, so here you can see the explanation for a comparator. The op-amp or comparator compares one analog voltage level with another analog voltage level or some preset reference voltage Vref, and produce an output signal based on this voltage comparison. So depending upon which input is going more and which input is going less, depending upon their values, the output is going to switch between two levels, either plus VCC or minus VCC. It is called as plus saturation or minus saturation. So in other words, the op-amp voltage or the op-amp voltage or comparator compares the magnitude of the two voltages inputs and determines which is the largest of the two. Okay. So seeing the output waveform, you can determine which input is largest of the two inputs, which input is largest. Okay. Then a comparator circuit, if you go to give the explanation, the a device that consists of two input terminals in which a reference input signal is fed to one terminal and the actual value of the signal is fed to another terminal. Then an output signal is generated at the output terminal based on the difference between the two input signals fed to the two input terminals. This generated output signal is either zero, you can say it as minus VCC or minus saturation level, or 1, you can say it as plus VCC or plus saturation level. Okay. The two analog input terminals are represented as V plus, V in, and V minus is Vref in the above or comparator circuit. The digital output is generated at the output terminal V naught, which is called as V out. The output signal of a comparator circuit is given as V plus greater than V minus, that is V in greater than Vref, will give you the output as logic 1, and when V in is less than Vref, it will give you the output as logic 0. So here it is high. So this you can take it as plus VCC or plus saturation level, and this you can take it as minus VCC or minus saturation level. Minus saturation level. Okay, so output will vary between two levels depending upon whether the input voltage is greater than reference voltage or input voltage is less than reference voltage. So generally, comparators are used in the devices such as relaxation oscillators, analog to digital converters (ADCs), and also in the devices that are used to measure analog signals. The comparators consist of high gain differential amplifiers, and we can use an op-amp as a comparator circuit. So as an example, in open loop, we have shown a comparator circuit. Now here you can see if the a comparison between the analog input and Vref is done, then the output looks like this. Okay, so here you can see this is your input voltage, this is your input V in, this is V in. Okay, This is Vn, and this line what is shown is Vref. This is Vref. So whenever Vin is greater than Vref, you can see the output is positive saturation. Positive saturation. And whenever input is less than Vref, the output is negative saturation. Okay, negative saturation. Okay, now these are input and output waveforms for positive reference voltage. If you similarly take a negative reference voltage as shown in the second figure here, so reference voltage we have taken down. So this is the reference voltage, this is Vref. Okay, this is Vref, and this is your Vin. Okay, now here whenever the input signal, this signal is more than the reference voltage, the output is at plus saturation, and whenever the input signal is less than the reference voltage, the output is at negative saturation, minus Vset. Okay, so similarly you will get a square wave type waveform at the output. Okay, so what are the limitations of open loop op-amp configuration? Okay, so firstly, in the open loop configuration, a clipping, that is some part will be clipped of the output waveform. Clipping of the output waveform can occur when the output voltage exceeds the saturation level of op-amp because the gain is very high. Because the gain is very high, the output can be clipped. So instead of getting an analog output, a correct waveform, it can be clipped. It can go to saturation. And this is because of very high gain of the op-amp. This is the first drawback of open loop configuration. You cannot control the gain. Okay. Secondly, the open loop gain of the op-amp is not a constant and it varies with changing temperature and variations in the power supply. Also, the bandwidth of most of the open loop op-amps is negligibly small. This makes open loop or configuration of op-amp unsuitable for AC applications. The open loop bandwidth of the widely used 741 IC is approximately 5 Hz, but in almost all AC applications, the bandwidth requirement is much larger than this. So again, this has become a limitation of open loop configuration. Thank you, students.